Hi everyone, my name is Ravi Prakash and welcome to the 8th class of remainders. Okay, so now we'll discuss about the questions, some questions of Wilson's remainder theorem, and then we'll go to digital sum. Okay, so questions, few questions we'll do. 50 factorial by 47 square, what is the remainder? Okay, so the question is 50 factorial upon 47 square, what is the remainder? Okay, so it's a very good question. Let's solve it. See, now we've discussed this concept earlier of cancellation factor, right? Of cancellation means, suppose if it is like 15 by 20, that remainder I need to calculate. So if I cancel it by 5, it is cancelled by 5, right? Like 5 3 ja and 5 4 ja. So I've cancelled by 5. So 3 by 4 remainder is always 3. Okay, 3 by 4 remainder is 3. But I should multiply by the cancelled term. I should multiply by the cancelled term called cancellation factor. Right, that is 5. I've cancelled by 5. Okay, 5 3 ja, 5 4 ja. So 3 into 5 will again give me 15 as the answer. Like 15 by 20, if I have to calculate the remainder, then 15 is the answer, right? Obviously, because the numerator is less than denominator. So in remainder, we don't cancel anything, right? But if at all we need to cancel, right? If at all we cancel, so no issue. We can cancel here 5 3 ja, 5 4 ja. So 3 by 4 remainder is 3. But whatever term I have cancelled, I need to multiply it back. Okay, so multiply it back by 5. 3 5 ja 15. So 15 is the answer. Okay. Now, so 50 factorial by 47 square, right? So we know that in 50 factorial, that is from multiplication from 1 into 2 into 3 into till 50, there will be 147. Okay. So let's cancel that 47, right? I can write like, okay, because the concept here is, if here is 147 in denominator, then it is a prime number, right? So 46 factorial by 47, the remainder will be what? It will be minus 1. This is the concept, right? This is the concept behind this question. Okay, so it's like 46 factorial into 47 into 48 into 49 into 50. This divided by 47 square. Now this can get cancelled, right? Because they both have numerator and denominator. I can cancel 47. Now remember, I need to multiply it back. Remember, I need to multiply it back in the last. Always multiply the answer with 47. Always multiply the answer with 47. Multiply the answer, okay, with 47. You always remember it. Okay. So now 46. So this question becomes like, okay, this question becomes like now 46 factorial into 48 into 49 into 50 divided by 47 remainder. This we need, okay? So now I know that 46 factorial by 47. What is the remainder? It is minus 1. It is minus 1. Okay. 48 by 47. It is how much? It is plus 1. 49 by 47 plus 2. 50 by 47 plus 3. Right? So how much it comes? How much it comes? It comes out to be minus 1 into 1 into 2 into 3. It is minus 6. So if remainder is minus 6 and denominator is 47, I can write the remainder as what? I can write the remainder as 41. I can write the remainder as what? 41. So positive remainder is what? 41. What is the negative remainder? Minus 6. So for find minus 6 to the negative remainder and 47 as denominator, I can write it to be 41 and multiply the final answer with 47. The term which you cancelled, right? So 41 into 47. What is the answer? Answer will be what? Answer will be 1927. So 1927 is the answer for this question. Okay. So in remainder, whenever you cancel any term, at last always multiply it back. Okay. I explained this concept here. At last always multiply it back. Fine. Okay. Next question. Next question is 35 factorial by 74. What is the remainder? 35 factorial by 74. What is the remainder? Right. Now you have to observe this in this kind of question, right? It is very easy question, right? But if you observe it, otherwise it becomes a very difficult question. So if you observe, it is 74 here. So 74 means, and here it is 35 factorial. So 74 is not a prime number. Okay. And for 35 factorial, even sense it like this. For 35 factorial numerator, the next prime number after 35 factorial, the next prime number after 35 is what? 37. So if it is 37, then 35 factorial by 37, that remainder would be 1 by Wilson's remainder theorem. Okay, p minus 2 factorial upon p, remainder is 1. So you can get here. Okay, but what I need is 35 factorial by 37. This is a USP of the question. If you get this, you can get the answer now. So you can like 35 factorial upon 2 into 37 now. Okay, what is this? This is Chinese remainder theorem. This is Chinese remainder theorem. It's split in denominator. It is Chinese remainder theorem. So you should split like this, that both the parts are co-prime. Okay, so 2 and 37, both the parts are co-prime. Okay, now first part, 35 factorial divided by 2 remainder will calculate, and next we'll calculate 35 factorial divided by 37 remainder. So 35 factorial by 2, what is the remainder? Remainder is 0, because 35 factorial is a big number. Multiplication from 1 into 2 into 3 till 35 divided by 2. So obviously 2 will get cancelled somewhere in between. So what is the remainder? Remainder is 0. Okay. 35 factorial by 37. This is by Wilson's remainder theorem. P minus 2 factorial upon P. What is the remainder? It is plus 1. Okay. So now it is by Chinese remainder theorem. It is by Chinese remainder theorem. So a number when divided by 2, remainder is 0. So number is of the form 2x plus 0. Same number when divided by 37, remainder is 1. So number is of the form 37y plus 1. Right. And we know that we did this in Chinese remainder theorem, that the first number, the smallest number satisfying this expression is the answer. Right. So you can directly observe it, right? Means you can simply observe it because it is 2. So left side is just 2x. So left side is just 2x. That means an even number, a multiple of 2, right? So at what value of y will I get as this an integer? At any multiple of 2. So that's for surely at y is equal to 1, right? At y equal to 1, I'll get x as an integer. If I put y1 here, what is the answer? So answer for this question will be 37 into 1 plus 1, that is 38. So 38 is the answer. Even if you put at y equal to 1, you will get x equal to 19. So x 19 will put here. Again, answer will be same. 2 into 19, 38. Okay. So your wish. Okay. So again, this is a good question. You have to observe these things. Okay. Fine. Let's move to digital sum now. Let's move to digital sum. Okay, digital sum. Now what is digital sum? Okay, see, digital sum is basically, we discussed this concept in the basics also, right? What is digital sum? So digital sum is basically adding the digits of a number, till we get a single digit. Okay, adding the digits of a number till we get a single digit. Fine. For example, what is digital sum of? Okay, for example, digital sum of 9, 8, 4, 3, 6, 7. So what is the digital sum of this number, right? So we'll just simply add the digits. That is 9 plus 8 plus 4 plus 3 plus 6 plus 7. How much it is? It is 17 plus 4, 21, 24, 30, 37. It becomes 37, right? Now, again we'll add it, right? Adding the digits till we get a single digit. So again we'll add it. 37 is again 3 plus 7. That is equal to 10. Now 10 is again not a single digit. So again I'll add it. So 1 plus 0. So that is 1, right? So this is a digital sum. Therefore, digital sum of 984367 is equal to what? Is equal to 1. Okay, there's a digital sum, right? There's some exclusive property of digital sum. Okay, you see, digital sum will be same for numbers in AP with common difference of 9. Okay, so digital sum will be same for numbers in AP with common difference of 9. Okay, so every time digital sum will be same. Fine. For example, you see, I got digital sum 1 as 1, right? Now when I'll get next time digital sum 1, so I should add 9 here. 1 plus 9 is what? 1 plus 9 is 10. Okay, I should add 9. Okay, so again 10 means again digital sum 1. Again when I will get next time digital sum 1, so 10 plus again 9, that is 19. So again in 19 I'll get digital sum 1 because 1 plus 9 is 10 and 10 is what? 1 plus 0 is 1. Again next time digital sum 1, so I'll keep on adding 9, 28. Again digital sum 1, 2 plus 8 is 10, 1 plus 0 is 1, right? So like this every time, okay, like this every time. Any AP of common difference 9 will give you digital sum as 1, right? For example, take one more example, like suppose 34. So digital sum of 34 is how much? 3 plus 4, that is 7. So when you will get digital sum next time 7? So after 34, start forming an AP of 9, right? Common difference of 9. So 34 plus 9, right? 43. You see digital sum again 7. 4 plus 3, 7, right? 43 plus 9, 52. You see again digital sum 7. 5 plus 2, 7. Like this, right? It goes on like this. Plus 9, sorry. Should be plus 9. Okay, should add plus 9, so 61. Keeps on, right? So all will have digital sum 7. Okay. So since common difference of any two consecutive numbers have with common difference of 9 has got same digital sum, therefore any number divided by 9 and taking the remainder will give me the digital sum of that number. Okay, so any number divided by 9 and taking the remainder will give me the digital sum of the number, because all the numbers have got what? Difference of 9. Okay, so in multiples of 9 we are adding, so just divide by 9, so all that multiples will get cancelled, will become 0, so only digital sum will be left. So any number by 9, very important point, any number by 9 remainder is the digital sum, right? Now one important point is digital sum will be equal to 9 when number by 9 remainder comes to be 0, right? 0 can't be the digital sum, right? 0 can't be the digital sum. So 0 can't be the digital sum. Okay, so any number by 9 remainder is 0. Okay, so digital sum is how much? Digital sum is 9. Because see, whenever suppose this is the number 585 is a number, right? So what is the digital sum of 585? So I know digital sum of 585 is equal to 5 plus 8 plus 5, that is equal to 18. Again 1 plus 8, that is equal to 9. So 9 is the digital sum of 585. That we can also get by 585 divided by 9 remainder. Sorry, 585 by 9 remainder. Okay, so 5 plus 8 plus 5, 18, right? So if you divide this number by 9, it is completely divisible by 9, so that remainder will get 0. That doesn't mean that 0 is a digital sum. So if remainder is 0, that's what written. If remainder is 0, that means digital sum is 9, not 0. Okay, therefore in this case digital sum is equal to what? 9. Whenever remainder gets 0, that means digital sum is 9. Digital sum can't be 0. We are adding digits, right? It can never be 0. Okay, see, if any number you take, like suppose 6483, what is the digital sum of 6483? 6 plus 4 plus 8 plus 3, that is 21. That is 2 plus 1, that is 3. Okay, let me write here. Okay, that is again how much? 21 is 2 plus 1, that means 3. That you can also get by 6483 divided by 9 remainder. So what is the rule for 9? Sum of the digits, right? So 6 plus 4, 10, 18, 21. 21 by 9. What is the remainder? It's 3 only. That's it, right? So any number, right? So you written that any number divided by 9 remainder will give me the digital sum of that number. Will give me the digital sum of that number. Okay. Right? Very point. Okay. Let's do a question here. What is the digital sum of the following? What is the digital sum of the following, right? First one is 358 raised to 46. 350, what is the digital sum of 358 raised to 46, right? So I told you what is digital sum? Any number divided by 9 remainder will give me the digital sum, right? That's it. That means 358 raised to 46 by 9 remainder will give me the digital sum. So now I can simply apply Euler here. Both are co-prime. Apply Euler. 358 by 9 remainder and 46 by 6 remainder. What is 6? 6 is the Euler number. Euler number of 9 is equal to 6. 9 into 1 minus 1 by 3. 3 is the only prime factor of 9. Okay. So how much you get here? Now for divisibility rule for 9 is what? Simply sum of the digits. We'll discuss this in divisibility rules. Okay. Simply sum of the digits. So 3 plus 5 is 8. 8 plus 8 is 16. 16 by 9. What is the remainder? It is 7. Okay. And 6 7 is 42. What is the remainder here? 4. 7 raised to 4 divided by 9 remainder. Now we can solve it separately. 7 raised to 4 divided by 9 remainder can be splitted as 7 square into 7 square by 9. Okay. So 49 by 9, what is the remainder? 9 5 is 45. Remainder is 4. So 4 4 is 16, right? So 16 by 9. What is the remainder? Remainder is 7 only. So 7 is the answer, right? Therefore, digital sum of 358 raised to 46 is equal to how much? Is equal to 7 only. It is equal to 7, right? So how do you get a digital sum? Divide that number by 9. Any number by 9 taking the remainder will give me the digital sum. Any number by 9 dividing by 9 taking the remainder will give me the digital sum. Okay. Next question. Question 2. What is digital sum of? Question 2. What is digital sum of 32 factorial? Okay. So again same thing we'll do. 32 factorial will divide by 9 and take the remainder. Okay, 32 factorial will divide by 9 and take the remainder. So obviously 32 factorial has got multiplication from 1 to 2, 3, 4 till 32. So obviously 9 will get cancelled somewhere in between, right? Somewhere in between 9 will get cancelled. What is the remainder? 0. That means whenever I told you, right, whenever you get digital sum as 0, whenever you get remainder as 0, digital sum can never be 0. Okay. So whenever you get remainder as 0, remainder as 0. That means what is digital sum? So digital sum is equal to how much? 9. Okay, so 9 is the answer for this question. 9 is the answer for this question. Okay, clear? Okay, next question. So how many numbers from 100 to 800, both inclusive, will have digital sum of 6? This is a question here. Okay, so digital sum, we know that digital sum forms an AP with common difference of 9. Okay, so if you get 6 here, 6. So when does the next number will have digital sum 6? After the common difference of 9, that is 15. Then again add 9, 24. Right? So like this, all these numbers will have digital sum of 6. So what is the general form of this number? So general form of this number is what? First number is 6 and we're adding always 9. So we're adding always what? In multiples of 9. 9, then 18, then 27, right? So that is 6 plus 9k. So digital general form of this number is what? 6 plus 9k, right? So we have to just see the values for which k is more than 100, right? So you can just observe, okay, just reach closer to 100, right? I need between 100 to 800. So simply observe multiple of 9 near 100. So if k is equal to 11, number is what? If k is equal to 11, at k equal to 11, number becomes what? 6 plus 9 into 11, that is 105, right? It just exceeds 100, right? Just exceeds 100 now, because at k equal to 10 it will be 96 only. So at k11 it is 105. So that means 105 is the first number between 100 to 800 with digital sum 6. So just simply calculate the value of k. That simply from k is equal to 11 to what is the last value? Till 800, right? Let's just simply observe a multiple of 9 near 800. Okay, around 90 times. Around 90 times, right? That means let's say around at k equal to 90, 6 plus 9 into 90. So 9 9 81, it becomes 816. But I want just less than 816, just less than 800, right? So obviously 9 will be less one time. Okay, it is by 9k. So if I have to subtract more than 16, I have to subtract 2 times k, because 2 times k will be what? 9 into 2, 18. So if I subtract 18, it is under 800, right? That means k equal to 88 will do. At k equal to 88, it is 6 plus 9 into 88. Okay, what is 6 plus 9 into 88? 798. 798 is the last number just before 800. Okay, so 798 is the last number just before 800. So it becomes what? It becomes k equal to 11 to k equal to 88. Simply you can observe it, right? To k equal to 88. How many numbers here? 11 to 88. Since both have to include, so difference plus 1. 77 plus 1, right? That is 78. So 78 is the answer for this question. 78 is the answer for this question. Okay. I hope it is clear, this digital sum concept. Okay. So we'll do next question here. Next question is, write it down. See, a is equal to 4 times 8 raised to 4 times 7. Okay. B is equal to sum of digits of A. C is equal to sum of digits of B. D is equal to sum of digits of C. And like this it is going on till sum of digits of X is equal to X itself. Okay, so what is the value of X? What is the value of X? Okay, see, this is a very good question actually, right? Because this question talks about the comprehension of a problem, right? How do you comprehend a problem? Okay, so like A is equal to 8888 raised to 7777. Okay, Now B is equal to sum of digits of A. That means now A is a big number. Okay. Now B is equal to sum of digits of A. Number gets a bit shortened, right? When you add digits of a number, obviously number will get shortened. Okay, for example, 9, 4, 3, 6, 8, 9. If you add the digits of a number, if you add the digits of a number becomes what? Number becomes 9 plus 4, 13, 16, 22, 30, 39. See, number gets shortened, right? It was a 6-digit number, now it's a 2-digit number. So when you add the digits of a number gets shortened. So now again, B is equal to sum of digits of A. So A is a huge number. 8888 raised to 7777. Now B is equal to sum of digits of A. So number gets shortened. C is equal to sum of digits of B. Numbers get further shortened. D is equal to sum of digits of C. Number gets further shortened, right? Till a point it reached where sum of digits of X is equal to X itself. Now this will only happen when X is single digit. Right, so this will only happen when X is single digit, because only sum of single digit is equal to single digit itself, right? That means sum of 8 is equal to 8, sum of 7 equal to 7, right? Otherwise, for any number, sum of digits of X cannot be equal to X itself, right? So very important point. That means this 8888 raised to 7777 was a huge number. Okay, and we have kept on adding the digits to get to a single digit as X. That basically means that we have to calculate the digital sum of this number. That's it, right? So digital sum of 8888 raised to 7777 is equal to what? Digital sum of any number is what? Number divided by 9 remainder. Okay, so 8888 raised to 7777 divided by 9 remainder. Okay, can apply Euler here. So it's like 8888 divided by 9 remainder and 7777 divided by 6 remainder, because 6 is the Euler of 9. 6 is the Euler of 9. Okay, 6 is the Euler of 9 now. What is the remainder here? So for 9, again, what is the rule? I've told you what is the rule. Rule is sum of the digits. So 8 plus 8 plus 8 plus 8, 32. Okay, so here you will get 32 by 9 remainder. That is 5. Okay, raised to, directly you can write here. Okay, so rule for 9 is sum of the digits. So 8 plus 8 plus 8 plus 8, 32. 32 by 9. So 32 by 9, remainder is what? Remainder is 5. Okay, so this part remainder is 5. Raised to 7777 divided by 6. Okay, so 7777 divided by 6 remainder. So divide this number by 6. What you will get? 6 into 12, 72, 5, 7, 9, 70, 50, 4, 3, 7. You will get remainder as 1. Okay, get remainder as 1. So 5 raised to 1. So you got 5 raised to 1 divided by 9 remainder. That is 5 only. So answer for this question is 5. That means digital sum of 8888 raised to 7777 is what? Answer is 5. So 5 is the answer for this beautiful question. Okay, thank you. So this is digital sum. Do practice such questions in the quizzes. Okay, thank you.